The next several lessons are about integrals involving different powers of different trigonometric functions. To be honest, they all just boil down to u substitution. The next few days are just u substitution. All I'm doing is giving you guidelines about how to use those u substitutions. So knowing the strategies is important, but you can achieve them just as well by sort of practicing and sort of working through and thinking about what's going to work. So this lesson is about integrals involving odd powers of sine or cosine. So if you've got an integral that involves sine and cosine, and one of the two of them, or maybe both of them, are odd, sort of this is what you can do. Your strategy should be, if, like for instance, let's say if sine is raised to an odd power, you can reserve one of those signs, like next to the dx, convert the rest of the signs into cosine by using this, and then just use a u equals cosine x substitution, and you'll find that the whole problem will work really well. This exact same strategy works great if you replace all of the sines with cosines and cosines with sines. So if it had said here, oh, if cosine is then raised to an odd power, then reserve one of the cosines and convert the rest into sine by moving this around, and then use u equals sine x as your substitution. I've got 3 examples of this, so you'll get a chance to see it when we do it. So this first example, you'll notice I actually started with one where both sine and cosine were raised to an odd power. Remember that the strategy is this: pick one of them, reserve one of those sines or cosines, and convert the rest of them into the other one, right? So if I decided to reserve one of the sines, I'd have sine to the 4th left. I'd have to do my substitution twice. I'd have to do 1 minus cosine squared and another 1 minus cosine squared. I'd have to FOIL the whole thing out. It seems like in this case it's going to be easier for me to reserve one of the cosines and convert the rest into sine. So let's look at what that looks like. I have the integral of sine to the 5th x times. Now the idea is that this cosine cubed, I'm going to reserve one of the cosine x's over here, and the rest of it, the cosine squared x, I can change into 1 minus sine squared x. Okay? And now the idea is, hey, now that I have this thing, notice that I have a cosine x that's waiting at the end, and everything else is in terms of sine. Right here, at this point right here, I am set up perfectly for a u substitution. If I make my u sine x, what's your du going to be? It's going to be cosine x dx. I mean, look at this. Cosine x dx is literally waiting there for you to be turned into a du. And all the rest of this stuff has sine x in it. So this integral becomes the integral of u to the 5th times 1 minus u squared du. And like in one quick step, every stitch of trig is gone, right? We just have to think about how you're going to integrate this. And this shouldn't be hard, but I mean, like, think about it for me. Like, how are you going to do that integral? Right? We'll need to distribute. We'll need to push that through. We'll get the integral of u to the 5th minus u to the 7th du. So when I do that, I'm going to end up with 1/6 u to the 6th minus 1/8 u to the 8th plus c. And then my last step is to take my u and substitute back in. I get 1/6 sine to the 6th power of x minus 1/8 sine to the 8th power of x plus c. And I mean, like, awesome. That's my answer. I mean, that's good stuff right there. I've mentioned before, like, a lot of times we get to the end of these problems, we're like, oh yay, we did it. God, that's a terrible answer. Fair enough. I really see all of these, like, advanced integration techniques as to look at what's possible. Like, we can do this. We can find the function that had this thing up here as its derivative, right? We managed to find that function, and that's exciting. So don't always, I mean, it's exciting when you get a nice, pretty, elegant answer, but we should have at least some other level of excitement over just the fact that we can finish these problems, that we're approaching a place where there are a few integrals that are not possible for us. So here's another example for us, right? So what I'd like you to do is pause the video and think through the original strategy. Think about what we're going to do for this problem. If you're feeling bold enough, even take the first step, and then check back in with the video and sort of make sure you're walking down the right path. The idea here is that only one of them is raised to an odd power. Sine cubed x is raised to an odd power. So the strategy says that we reserve one of those, and with the rest of them, sine squared x, we convert them into cosine. So I'll get the integral of the square root of cosine x times 1 minus cosine squared x times sine x dx. And again, right here, we have a great setup, right? The setup is, at the end of the problem, there's a sine x dx, and everything else in the problem is in terms of cosine. So the substitution that makes sense should be using u equals cosine x. It means your du will be negative sine x dx. So all you really need to do is sort of move that negative over. Negative du will be sine x dx. So now that I have that, I can rewrite my integral. This will be the integral of the square root of u times 1 minus u squared times negative du. I'm going to pull the negative to the front and put the du on the end. Once again, I mean, how awesome is this? Like, we did one little change in the beginning, we did a substitution, and right away all the trig is gone and we have a nice reasonable integral. Right, so let's actually process this integral. Before I do that, I'm going to have to simplify. This will be negative integral of u to the 1/2 minus u to the 5/2 du. So when we integrate these things, we're supposed to add 1 to the power. So 1/2 will become 3/2, multiplied by the reciprocal, will give me 2/3 u to the 3/2 plus 2/7 u to the 7/2 plus c. And then again, all we really need to do is take our substitution and, put it back into our expression. Negative 2/3 cosine to the 3/2 plus x plus 2/7 cosine to the 7/2 x plus c. A note on simplifying: a lot of times when I see two expressions that both have fractional powers in them, I'll be inclined to sort of like, I know usually I hate mixed numbers, but this is like 1.5 cosines, this is like 3.5 cosines, so why don't we just pull out like, a half of a cosine? And in fact, they both have a 2 also. We could factor out 2 times the square root of cosine x, and what I'd have left is negative 1/3 cosine x plus 1/7 cosine cubed x plus c. Now you might be thinking, oh, we could have pulled out another whole cosine also. Sure, we absolutely could have. Once you get to the step of simplifying, there are lots of possible options. I'm just sort of showing one of the possibilities. Okay. So here's my last example for us. It's a slightly more involved problem, but it should be sort of the same strategy, the same steps, same thing, right? So process for yourselves what the first step is going to be, and then sort of watch the video and see if you got that right first step. My thought here is that cosine is raised to an odd power, so I'm going to reserve one of them, and that means the rest of the problem is left to be cosine to the 4th x. Now, we haven't dealt with a cosine to the 4th x before, but what we're going to do is we're basically going to treat it as cosine squared x times cosine squared x. Okay? Now note, I'm not ready for the substitution yet because this part isn't all in terms of sine. I need to change these two guys on the top. So this will become 1 minus sine squared x times 1 minus sine squared x over the square root of sine x times cosine x dx. At this point, I would say we're more ready to do that substitution. We can say, yep, I'm ready to say that u is sine x, that du is cosine x dx, and as soon as we make that substitution, this thing becomes the integral of 1 minus u squared times 1 minus u squared over the square root of u. right? Oh, du. So now, again, like how am I going to do this integral? Hopefully you guys recognize I can sort of FOIL the top together. I can get 1 minus 2u squared plus u to the 4th over the square root of u du. And we're getting close here. What do we do anytime we have a polynomial on top and one single thing on the bottom? Anytime that happens, we sort of break this thing into 3 separate integrals, right? We will have the integral of 1 over the square root of u, so that's u to the negative 1/2. We'll have minus 2u squared over the square root of u, that'll be u to the 3/2. Then we'll have plus u to the 4th over the square root of u, which is u to the 7/2 du. Right? So now when you integrate each of these things, we add 1 to the power and multiply by the reciprocal. So this will be 2 root u. This will be minus, let's see here, 4/5 u to the 5/2. This will be 2/9 u to the 9/2 plus c. And my final step is to plug u back in. U was sine x. So we're just going to put sine x back into these things. So 2 root sine x minus 4/5 sine to the 5/2 x plus 2/9 sine to the 9/2 x plus c. This again is a problem that falls squarely into the category of, wow, that's a really ugly answer, but it also falls into the category of, oh my gosh, we did it. So hopefully, if you guys have some amount of fortitude left to be joyful, you can sort of have that sense of like, wow, like the number of integral problems that we have to run and hide from is getting smaller and smaller. So this entire video has been about how to deal with even and odd powers of sine and cosine. I'll see you in the next lesson.